Alright, so we are going to solve exponential and logarithmic equations now. So we're going to use all the stuff that you just learned. That's why it would have been better to cover 3-2 last time, but it was 8:30 and we were tired, so. And it's 8:30 now and we're tired. But at least we didn't take a test tonight. Alright, so how do we solve exponential equations? I already did this once. So these are the steps to solving exponential equations. If you can express each side as a power of the same base. So you try to rewrite the equation in the form of the same base raised to a power equals the same base raised to a power. If you can get that, then you can set the exponents equal. If you can get the same base. And then we're going to solve for the variable. So here we're going to do some examples. So we have a base of 3 over here. So that means we want to look, and this is an exponent of 2x plus 1. How can we rewrite 27 with the base of 3? You can take your calculator and you can put in y equals x squared. You can find
the third.
It's 3 to the third power, right? Now the bases are equal, means the exponents are equal. So 2x plus 1 equals 3. Now we solve for x. We subtract the 1. 2x equals 2 when we divide by 2. So x equals 1. And now we can check. We're going to take your calculator and put in 3 to the parentheses 2 times 1 plus 1. We can just put that right in the calculator to check. You do need the parentheses, so you do 3 to the parentheses 2 times 1, which is 2, plus 1, which is 3. So you're raising 3 to the third power, but that's 27. Okay, so remember you can check these. Okay, 4 to the x equals 32. So can we rewrite 32 with a base of 4? So we can try it. 4 squared, 16. 4 to the third power is 64. No. Okay, so what else can we do? Let's rewrite the 4 as 2 squared. And then can we rewrite the 32 as a base of 2? Yes, 2 to the 5th is 32. This is the power to power rule. We multiply, so that's 2 to the 2x equals 2 to the 5th. Now we have the same base equals the same base to different exponents. That means we can set the exponents equal 2x equals 5. Divide by 2. Sorry, x is 5 halves, or 2.5. Okay, we can check. Is 4 raised to the 5 halves, does that equal 32? Or 4 raised to the 2.5? 4 to the, you need parentheses if you're going to do 5 divided by 2, is 32. Or 4 to the 2.5 is 32. So we checked. All right, next one. Got to remember about negative exponents. We have a base e over here. Can we rewrite 1 over e to the 2x as e to the something? So, yes. E to the x plus 4 then will equal e to the negative 2x. Remember, if you have a, you can rewrite it as, you can bring it up like we brought the 6, 1 6 became 6 to the negative 1. The negative exponents. So now we have the same base, we can set the exponent equal, then we solve for x, get all our x's on one side, our constants on the other, divide by negative 3, x is negative 4/3. Okay, now we can check. We can put e to the negative 4 divided by 3 plus 4 in our calculator. And then we can also put in 1 divided by e to the 2 times negative 4 divided by 3. I'm going to put those in my calculator. The e to the x key is above the natural log, so you push second. Natural log, negative 4 divided by 3 plus 4. That's the left side of the equation. You get that number, 14.3919161. Okay? And then you do 1 divided by second natural log 2 times negative 4 divided by 3. And you get the same number, so that's checked. Guys see that? So you can check it. Okay, so there's your answer. Okay, so if I ask on the test for you to solve something by setting it to the power of the same base, then you need to do it that way. Any questions? Does it make any sense, or is your brain's dead already?
We're dead.
You're dead. About 2 hours ago, right?
5:59 p.m. with Morse code.
Before class started, yes. All right. The other way, we can use logarithms to solve exponential equations. To do this, we isolate or get the exponential expression by itself on one side. And then we take the natural log of both sides for bases other than 10. Or we take the common log on both sides for base 10. And then we're going to simplify using one of these properties. The natural log of b to the x will be x times natural log of b. We're going to, x is over the whole inside of the log, we can bring it out front. Natural log of base e of e to the x will just be x. This is because they have the same base, they're inverses, they undo each other. Same thing here, this is log base 10 of 10 to the x, that equals x. The bases match They're inverses, they undo each other. These are the inverse properties for natural log and log base 10, common log. Okay, so we're going to solve some more equations. So we need to get the e to the 7x by itself. Right now it's being multiplied by 4. So, did I go too fast? Were you still copying this stuff? Right? So you divide by 4, the e by the exponent, e to the 7x by itself on one side. And you're going to write equals, and you're going to leave some space and write 10,273 divided by 4. We're just going to keep that fraction. Now, because this is base e, we're going to take the natural log of both sides. So we isolated the e to the 7x. That's the exponential. Then we take the natural log of both sides. What happens on the left here? The bases match, and you're left with 7x. So 7x equals this whole thing, which is just a constant. And then you're going to divide by 7 to solve for x. So here's what x equals. This is the solution set in terms of natural logarithms. Express the solution set in terms of natural logs. There it is. Also, then use a calculator to obtain a decimal approximation correct to 2 decimal places. So we're going to put this in our calculator and get a decimal approximation of the solution. Natural log of 10,273. And then, do we close the parenthesis?
Yes.
No, because we're dividing by 4 inside the natural log. Good guess, good guess. I know you're already brain dead, so
Yeah, we all know.
sorry. Okay,
And then divide by 4.
and then divide by 7.
Okay.
And we get that it's approximately 1.12. Now to check, if you put in 1.12 in the original expression, you're not going to get 10,272, 273. So we're going to check by putting, it's 4 times second e to the 7 times second answer. Your calculator will save the answer. The second answer, second, the negative sign. That's your previous answer. And then when I hit enter, I'm going to get 10,273. Did you guys get how I did that? So I typed in my calculator the left side of this equation. This is my check. I did 4 times e to the 7 times answer. And I got that it was 10,273. Does anybody need to see, do you know where second answer is in the calculator? Second answer. It'll just give you the previous answer. So if you needed to save an answer longer than that, you'd have to use the store function and store it, but I never do that. It's just too hard to store something. I don't store it. I just use my previous answer. And if I've lost my previous answer, then I keep hitting second enter to get back to the previous answer. Okay. But you could have stored this somewhere too. It stored it in answer. All right, and the next one is 5 to the x minus 3 equals 137. So can you write 137 as a base 5? You know, 5 times to the first power is 5. 5 squared is 25. 5 to the third power is 125. 5 to the fourth is 625. Right? No, you can't. Unless you start, you know, maybe it's 5 to the 2.16. You know. Well, you're not going to do it that way. So this is base 5. So we're going to take the net, and the exponent's already isolated on one side. So we're going to take the natural log of both sides. Okay? Now, what we can do is bring this x minus 3 out front. So this is x minus 3 times the natural log of 5 equals the natural log of 137. Okay, earlier today I made the mistake of doing this problem the hard way. The easiest way here is, this is a constant. Go ahead and divide it out on both sides. And then you have x minus 3 equals that natural log of 137 over natural log of 5. And now we're just solving for x. We're going to add 3. Okay. So that's the answer in terms of natural logs. Remember, natural log of 137 is just a constant. Natural log of 5 is just a constant. But I want you to keep those until the end so you get your solution in terms of natural logs. And then you're going to put it in your calculator carefully and get the 2 decimal place approximation. So that's natural log of 137, close the parentheses, divided by natural log of 5. So that is approximately 3.06. Now, do you think if I put in 3.06 for x, I'm going to get 137? No. You're going to put in 5, this is your check, 5 to the answer minus 3, and you should get 137. 5 to the parenthesis answer, second negative sign, minus 3. Oh, what did I do wrong? 5 to
You'll have 3.
Did I forget to add 3? That's what it is. Okay, I forgot to add the 3. It's 6.06. Okay. So, that's the problem. All right, so I'm going to recall my last entry to get back when I divided those and hit enter, and then I need to add 3. Now I do 5 to the parentheses second answer minus 3, 137. Okay, and that's where we're going to stop. But I do recommend, I think I have integrity posted for the rest of the stuff. I really do recommend that you get a little head we will go over the rest of it in section 3.5, but see, we don't have time for review. So you will feel better about it if you go ahead and watch Tegris for 3.4 and 3.5, and then start on your math lab. So you can get ahead, because next week you're going to want to start on the test right away. You're not going to want to have to do all that math lab. So that's my suggestion, is to go ahead and watch Tegris. Thank you, guys.